Okay. What did you get?
It's 2.
2. Let's see. Wait. Oh, geez. That's the wrong bell work. We already did that one. All right, so here we'll go with this one and we'll work it together.
Wait, we haven't done the other one this way.
Oh, we didn't. That was with my other classes. Sorry. Because I wasn't here yesterday afternoon. That was yesterday.
So do you want us to just do this one?
We'll work this one together. So, but 2 was the answer, and for the other one was, does anybody have that answer? Yeah, I think so. Okay. So how do we know which one we're going to use? So we have a volume of 10 liters. So I'm just going to call that volume 1. And it's at a temperature of 23 degrees Celsius. So I know that's temperature. But we need to add 273. So that it means it's going to be 296. We change the temperature to 97. So that's going to be a T2 plus 273 gives me 370. And what is the new volume? So that's my V2. So I have T's and V's. So I go and I look at my equations and I see which one has T's and V's only. And that would be Charles. So
Are we going to get those all the way?
this will be on the board, yes. Except for some of these concept things, but yes. So V1, so 10 over 296 is equal to X over 370.
And when we write the volumes and the temperatures, do you mind if we don't put like that plus 273 thing and just do the degrees?
Yeah, however you want it, yeah. So what is X when we solve for that? 12.5, and our unit is volume, so liters. Okay, so I'm going to stress this to you that if you had this set up and you gave me X and your X that you gave me was like 11.5, but you had this setup, you just had the wrong answer, you're going to get most of your points. If you had this set up and you did 269, you inverted your numbers, and your answer here was less, but I see that you did the math right, I'm going to take a point off, but I'm not going to penalize you because your answer was wrong. I'm going to penalize you because you inverted your numbers, but not because your answer was wrong. You had the science, the math correct. Okay, that's why showing your work is very important, so I can see what you did right and what you did wrong. All right, have a volume at 7.87 milliliters. So, volume 1.
What's ATM?
ATM is a pressure. So, that is pressure 1. Bring the pressure down to 1.5. What's the new volume? So, I have P's and V's. P's and V's right here. So, I'm going to have 7.87 times 2.5, and that's equal to 1.5x, and x is what? 13.1, and my unit is milliliters. Okay, so if this was a test or quiz or whatever, setup is worth points, answers worth points, units is worth points. Okay, so we're going to talk today about Gay-Lussac's law. So Gay-Lussac was a French chemist, and what he saw was that the pressure and the Kelvin temperature were directly proportional, which means if I had my pressure versus my temperature, when I increase my temperature, I increase my pressure. So why would increasing what happens at the molecular level between temperature and pressure? Yes? Gay-Lussac.
3 on the second page.
So what happens as we start increasing the temperature? What happens at the particle level? Those particles start moving faster, right? Particles start moving faster, they start running into the container wall. And when they run into the container wall, what's going to happen to the pressure? It's going to go up. Okay? So this is a direct relationship. Always, always Kelvin in this unit. You're going to get mad because the next unit we're going back to Celsius, but this unit, always Kelvin. So we have P1 over T1 is equal to P2 over T2. So we say Gale drives a PT cruiser. So Gay-Lussac drives a PT cruiser. So Gale and PT.
Did you and your kids come up with that, or is that like something you found?
Just something, it's been around for a long time. Any questions? So let's do a problem. 2-liter flask. What kind of variable is 2 liter? Volume. Contains helium at a pressure of 685 torr. And it has a temperature of 0 degrees Celsius. So it's 200. What?
I thought we could have 0 Celsius.
We can't, so we added 273 to it. Now, we change, what would the pressure, so what's the pressure in that flask if the temperature is changed to 150 degrees Celsius plus 273? 423? It doesn't say anything else about volume. So the volume is constant. So the volume doesn't mean anything to us. So P's and T's, look at my equations and see which one has P's and T's only. And that would be Gay-Lussac. So P1 over T1 is equal to P2 over T2. So my temperature went from 273 to 423. So my temperature went up. So we expect pressure to do what? To go up. So let's plug it in. 685 over 273 is equal to X over 423. What did we get? 1061? 1061, and my unit is torr. Now, if you converted that to atmospheres, it wouldn't be wrong. You're just going to make me do some more work because I'll have to convert it to atmospheres. It's not wrong if you left it in torr. I didn't say to change it to atmospheres, so I would divide it by 760. Everything that's on the board right now, the equations and all this stuff besides the concept stuff, is on the board for the quiz or the test.
So, I'm confused. Do you want us to leave it in?
I don't do any more work than I have to do, so I would just leave it there. Okay, any questions on Gay-Lussac? All right, so now what we're going to do is, again, if you're in Keynote, this has all the fly-throughs, works it out for you. We're going to combine them. We're going to take Boyle, Charles, and Gay-Lussac and make them into one big equation. So what we say are peas and vegetables on the table. P1V1 over T1. Oh, on the back page? Yeah. So peas and vegetables on the table. So if we look Boyle's law. When we have Boyle's law, what do we hold constant? If P and V is in our equation, then we're holding T constant. In Charles's law, out of these variables, what do we hold constant? P. All right. Gay-Lussac, what do we hold constant is V. So now what we can do is do a couple of problems with this. Now I won't ask you what this relationship over here, this one changes. Pressure on one problem might they might have an inverse relationship. It's kind of a war between volume and temperature and pressure to decide who wins that war, which one made that ultimate change. And we're going to see that in this next problem. Okay. If a helium-filled balloon has a volume of 3.4 liters, volume 3.4 liters, and it has a temperature of 25 degrees Celsius plus 273, so 298, and we have a pressure of 120 kPa. What is its volume at STP? Can somebody tell me what STP means? One atmosphere at 0 degrees Celsius. So STP is standard temperature and pressure. So anytime you see STP, that's what it means. 1 atmosphere and 0 degrees Celsius. So my temperature is what? 273. And my pressure is what? If it's not 1 atmosphere, 101.3 kPa, yes. Everything that's on there, except for this stuff right here, will be on the board on the day of the test or quiz.
So, on the quiz on Friday, what is it's just going to be over like all we're learning right now, so it's going to be...
You'll have probably 5 math problems and 5 conceptual problems over the properties of gases. So we put our peas and our vegetables on the table. Okay. So before we solve, let's look at what happened in this problem. Temperature did what? 298 to 273. It dropped. What happened to the pressure? Pressure went from 120 to 101. It dropped. So, knowing Boyle's law, we expect volume to go up. Knowing Charles's law, we expect volume to go down. So we need to see who wins the war. So we got to see what happened to the volume. So let's solve it. So this is one where you cannot predict if it's right or not. You just have to do the math. So we're going to cross multiply these 3 numbers and cross multiply the other side. And we get X. In the calculator, you put all 3 of these numbers in there and get an answer. You can put these 2 numbers in there and get an answer and then divide. Or if you like to do it all in one step, this times this times this, divided by, open parentheses, 298 times 101.3, close parentheses. What did you guys get? 3.7. And our unit is liters. So what happened to our volume? Our volume went up. So who won the war? Boyle or Charles? Boyle. Boyle won. Okay? Charles, we would have expected the volume to go down. But the volume didn't go down. The volume went up. So that means pressure is what ultimately made the change in this problem. Yes?
How did you use the STP to find 101.3?
Okay, because STP is 1 atmosphere. So 1 atmosphere, and we are in the unit of kPa. So I go over here to kPa. Okay? Any other questions?
It's a constant,
STP, yes. Anytime I say something's at STP, you know it's at 0 degrees Celsius, 1 atmosphere. On the day of the quiz or something, you're going to go, Mrs. White, you did not give me enough information to solve this problem. And I'm going to go, yeah, I did. And you're going to go, like, no, you didn't. And you're going to sit there and argue with me. And I'm going to go, yes, I did.
I won't argue with you, I promise.
It's just like, there's not enough information.
Oh, Ms. White, are you recording?
Yes, I am.
I don't even care. Your sub yesterday was a little crazy. I can't lie about that.
Whoa, wait.
No liability.
Law. This law, just go to the back of your notes, please. And the very last page of the actual guided notes. And we're going to go over one law that, for some reason, got left out.
You sure about that?
I thought that was the one that we did yesterday.
100%.
No, that got left out of the homework.
Oh, okay.
Just this extra space right here, some extra space.
Right here?
Yeah, that's fine. Okay, so the last law one of the last laws we're going to talk about is called Avogadro. So this is Avogadro's law.
6.02 times 10.
That is his number.
Bro, I'm so proud of you.
So Avogadro's law says that if I take the number of moles, which is N, and have it has a direct relationship with the volume. So I have a balloon and I blow it up, put my air, so it has so many moles in it. Well, I take it and I was like, it's not big enough. So I add more volume in it, which means I did what with the number of moles? I added more particles, so that goes up. So it's a direct relationship, volume versus the number of moles.
That's an N.
That's an N. V over N.
You said moles, though.
N. Moles is N.
So the ones that have, okay, so like the
Whoa.
Yeah, yep,
those are right.
yep, yep. So, yes, Abby's ahead of me. So, if we had to come up with this equation, would we want to multiply V and N, or do we want to divide them? We want to divide them. So V1 over N1 is equal to V2 over N2. So you have a balloon, and it has, it's a 10 liters, and there's 2 moles of your gas in there. You add another mole, so now it has a total of 3 moles in there. What is the new volume? 15? Yeah. 15?
Yeah, it's 15.
So X is 15 liters. So, to make it even better, we can take pressure, our P's and T's, and put them on the table with some moles.
That's another.
You don't have any homework with something like this. I just want to show you that we can do this. So if I have P and V, what law is it? Just P and V. Whose law is P and V? Boyle's. If I have T and V, whose law is it? Charles. If I have P and T, Gay-Lussac. And if I have V and N, Avogadro's.
Are you the ones that we can call avocados?
Well, somebody said that.
Are there any questions? So your homework is Gay-Lussac 1 through 5, combined 1 through 5, and Avogadro 1 through 5. If you are not getting the answer that you think that is out there to the side, I would go back and reread the problem and see if you're missing some key words, because that has happened.
Sounds like a duel to me.
All right, there you go.